Hey, this is Derry Zangane. I'm going to show you a quick demo on how the hybrid storage pool affects workloads on the Oracle 7000 storage series. So first thing I wanted to show you was quickly um, the hybrid storage pool architecture, in a nutshell. Not the entire thing, but just show you at a high level what it is and what it does. So the hybrid storage pool is composed of a couple of different components. First thing is lots of CPU processing power inside the controller. So the current edition has either, in the 7420 series, has either 64 cores or 80 cores. So lots of processing power. We're able to use all those cores. Underneath the OS is the Solaris technology that can take advantage of all those, and it's very good at multi-threading and things like that. Something else interesting about it is the huge amounts of cache or DRAM within the system. So in a single cluster, we can have up to 2 terabytes of DRAM, which is a very large amount and gives us a huge performance increase. As well as we have a couple of different tiers of flash disk. In the controllers, we have up to another 4 terabytes of read flash devices that are in the controllers. And then within the disk shelves themselves, we have these write optimized SSDs, or what we call ZILs, ZFS intent logs. Logzillas is another name for them. But so what the hybrid storage pool is composed of is some amount of these read flash devices, some amount of write flash devices, and some tier of disk. Yeah, either 15K drives or 7200 RPM drives. Either one we can use. Um, and it works dynamically. So what happens is when a write comes in from an application, it hits our DRAM, and then what is done is, if it's a synchronous write, we will immediately send a copy of it over to the write flash. As soon as it hits that write flash, we send the ACK back, or the acknowledgement back to the application, and they go on their way. What ZFS then does is it pulls up every 5 seconds, usually about every 5 seconds, will pull up all those writes that happen in DRAM and then flush them down to disk. So the write flash devices act as a really large, you can think of it as a battery back cache or NVRAM on other systems, but we have a much larger amount of both cache up here and cache in the NVRAM. We can have up to 96 of these devices currently, which would give you about 7 terabytes of flash. Usually you don't need anything close to that, but we do support that much. And then as data ages out of the cache, instead of just ejecting it out of cache, we would then move that data or write it over to our read flash devices based on the algorithms in the system. So let's take a quick look of exactly what this looks like. So here you see I have a system running with a workload. It's just a basic virtualization workload, and I have some different things going on. If we drill down to analytics, you can see I'm doing 11,000 IOs per second. Maybe we're interested in also seeing, let's take a look at what the latency is. We don't have anything above 7 milliseconds currently on this workload. The majority of it, is well below sub-millisecond. So very fast, very high latency. And let me show you the storage pool. The storage pool we're actually using is a single shelf of disk. I have 2 pools, one with each shelf, and I'm using 4 of the log devices within the pool. So I'll show you right now. What I'm sitting on is, and the pool is double parity. So if you go into the pool, I'm using RAID 6, like it's called RAID Z2 in ZFS world. But you see I have 18 drives, I have 2 hot spares, and I have 4 log devices. Those are the write SSD devices. So I have those in this pool. So a pool that's really not set up at all for any sort of high performance. You wouldn't typically expect high performance out of this, but we're actually getting very decent performance right now. We're hitting about 11,000 IOPS. We could probably do more than that. I have a number of, if I drill down on by file name, I can see what's running on this NFS workload. And what we can see is I have a couple of virtual machines, PMDK files, each doing the workload. You could drill in on those as well. We'll save that for a different web session, but you can see exactly what's going on, who's doing what our latency is, and performance is great, right? We're doing very low latencies, customers happy, But in a typical environment that doesn't take advantage of the hybrid storage pool, the write SSDs, the read SSDs, uh, what you would see is much slower performance. You wouldn't see this many IOPS at all. And let me show you an example of that, of how this works. So if we go over to the actual pool where I have these things stored, you can see there's different settings for the data store or for the share itself. And one of the big ones is the synchronous write bias setting. That tells the share or the project whether or not I want it to use those ZILs or write SSD devices. And latency says use them, throughput says don't. So let me change it to throughput and show you the difference the hybrid storage pool makes. So I just made that change, and if I go back to analytics, what we'll see is an immediate drop in IO performance. So we went from an average of 11,000, now we're sitting down at the 2,800, which you'd probably expect from 18 7,200 RPM drives used as a RAID 6 type environment, dual parity environment. The other interesting thing you see is, and look what happened to our latency heat map. Now all of a sudden we have latencies that are hitting 180, 190 occasionally. We still have quite a few that are sub-millisecond, but we have a lot that are, just not okay, right? A customer that's getting 61 milliseconds, 71 milliseconds is not going to be happy. At this point, you've overloaded what these 18, 7200 RPM disks could do without the hybrid storage pool. And that shows you an example of that. You can see the VMs themselves have dropped dramatically. But what's nice is with the hybrid storage pool, we can change that instantly. We could use the analytics to also see if we need more write SSDs, do we need more read SSDs, all that sort of thing. So we'll go back, re-enable that, go back to the analytics screen, and it's looking good. Performance jumps back up. So that is the hybrid storage pool in a nutshell. Thanks a lot.